All right, today we're going to be talking about equations and how to solve them. An equation is a mathematical sentence that contains an equal sign. So 5n equals 25. So how do you solve an equation? To solve an equation, replace a variable with a number that makes the equation true. This number is the solution. Now that's how you first start off, kind of like a guess and check. But we're going to teach you how to solve them algebraically. So before we begin, we need to understand what parts of an equation there are. Now, equations can start off one-step equations where they're simple and easy, and they can become much more complicated. We're going to start easy today. In later videos, we will go through two-step and multi-step equations. So the first part of an equation is the entire thing. So as you notice, we have 5x plus 11 equals 71. So this entire thing is the equation. Why? Because one side we have this, we have equal sign, and we have equals 71. Now notice right here it says an expression. Expression is when you have the 5x plus 11. I can't solve for it. Now expressions, I can combine like terms. We're going to talk more about that later. But I can't solve for it. An equation, you can solve for it. Now, as you notice, the operator is the operation you're doing, adding, subtracting, multiplying, dividing. Now the variable is the letter or symbol that represents the unknown quantity that we're solving for. Coefficient. The coefficient is a number in front of the variable. And a constant is a number just by itself. So we have 11 and 71 that are constants. All right. So let's take, if we had 5n equals 25. Now this is a simple one-step equation. Now I know most of you could do this in your head. So what you're really just asking is 5 times what equals 25. But how would I solve this algebraically? So first thing you have to ask is, what's next to the n, a 5? If a number is right next to a variable, what does that mean? Does it mean we're adding, subtracting, multiplying, or dividing? If a number is right next to a letter, it means we're multiplying. So what we're going to do is to isolate the variable, which means to get it alone, we're going to do the inverse, which is kind of like doing the opposite. So if I'm multiplying by 5, what is the inverse? What's the opposite of multiplying by 5? That's right, dividing by 5. Why do I divide by 5? Because what's 5 divided by 5? 1. What's 1 times n? Just n, because 1 times anything, and you keep the same number or same variable. So, just like in fractions, whatever we do to the top, we do the bottom. When in an equation, we have to keep things balanced. If you noticed at the very beginning, we had a balance. Because again, we have to keep things balanced. I always use the example of my kids. I have 2 kids at home. If I buy one kid something, I have to buy the other kid something. Otherwise, my life is not as easy as it needs to be. So if I divide the left side by 5, I'm going to divide the right side by 5. And then 25 divided by 5 is 5. Again, we already know the answer, but we can plug it back in to make sure. Plug this back into n, and 5 times 5 does equal 25, so we solved it correctly. Next problem we have is x over 3 equals 6. Now, in elementary school, a lot of times the only division symbol you use is this. In middle school, most of the time we use a fraction bar, which is a division bar. So what this problem basically is saying is x is divided by 3, some number divided by 3 equals 6. Again, a fraction bar, same thing as a division bar. So we need to isolate the variable. So what am I doing to the x right now? I'm dividing by 3. What's the inverse or opposite of dividing by 3? That's right, multiplying by 3. Oh. Oh, nuts. How did that happen? Multiplying by 3. Okay, and whatever you do to the left side, you do to the right side. I did it again. This equals 18. Okay, so Mr. Hewlett, why? Okay, so I'm dividing by 3. Why did I multiply 3? Because again, it's the inverse. The opposite of dividing by 3 is multiplying by 3. So how'd that cancel out? Because there's no point in multiplying by 3 and then dividing by 3. Let me show you an example. Let's just say we'll take 3. And you can pick any number you want, but we'll go ahead and do it by 3. What's 3 times 3? 9. What's 9 divided by 3? I go back to the original number, and this would work with any number I picked. Let's do one more example. Let's pick 5. What's 5 times 2? That's right, 10. 10 divided by 2 goes back to 5. So why am I showing you this? Again, if I'm dividing by 3, if I multiply by 3, those numbers cancel out. And then again, whatever you do to the left side, we have to keep things balanced. Whatever I do to the left side, I do to the right side, and 3 times 6 is 18. So x equals 18. Let's see if that's true. What's 18 divided by 3? 18 divided by 3 is actually 6, so we did it correctly. All right, all right. For this problem, we have x plus 2 equals 4. I need to isolate the variable. So what am I doing to the x currently? I'm adding 2. What is the inverse or opposite of adding 2? That's right, subtracting 2. Because again, I need to get that 2 away. If it's positive 2, the inverse is negative 2. So 2 minus 2, that's right, gives you 0. So we've zeroed it out. There's no longer a constant on the left side of the equal sign next to the x. Have to keep it balanced, so whatever you do to the left side, you do to the right side. So 4 minus 2 is 2. So we're going to plug it back in to make sure we did it correctly. What's 2 plus 2? Does equal 4, so we have solved this correctly. So again, on this one, isolate the variable. Look at what you're doing on this one. We're not multiplying or dividing like we were on the other two. We're adding 2. The inverse of adding 2 is subtracting 2. Subtract 2 on this side, subtract 2 on this side, and you get 2. X equals 2. All right, for our last example, we have x minus 5 equals 2. Okay, so we need to isolate the variable. So what am I doing to the x currently? So think of this. I need to get the x on the left, all the numbers on the right, all the constants on the right. So right now I have negative 5. So I'm subtracting by 5. What is the opposite or the inverse of subtracting by 5? That's right, adding 5. So I added 5 to this side. It zeroes out because negative 5 plus 5 is 0. So whatever you do to the left side, you do to the right side. So x equals 7. So we can plug it back in. 7 minus 5 equals 2. And so we did it correctly. And now we know the missing or the unknown variable value, which is 7. So I hope this has helped. An equation is a mathematical sentence that contains an equal sign. Again, since it has an equal sign, we can solve it. As you saw from all the other examples, we are trying to isolate the variable. Isolate means to get alone. We're looking at what we're doing to the variable, what operation, and then we do the inverse, kind of like we do the opposite. We always have to keep it balanced. Whatever you do to the left side, you do to the right side. And of course, once you have your answer, you're going to plug it back in to make sure it worked. Well, I hope this has helped. And if you need any clarification or additional help, please feel free to email me at jhewlett@leisd.ws. Thanks.